Good morning. So it's Friday. We've got all of our chess pieces now turned. We are going to get started on really our first pretty simple, straightforward fourth axis fluting. Fluting, I think, I have to go back and look at all of the prints, but I think the fluting is going to remain the same or really close to the same on all of them. We may make some modifications as we go. But I'm looking at a bishop and the pawn right now. Those look the same, and I think most of them, as far as the bottom work, the fluting itself, it's going to go in the bottom. Looks pretty similar on all of them, so I don't think that we'll have a ton of variation. There'll be some small variations. They're not identical, but they're pretty darn close. So we can probably use this fluting for more than one program. The first two that we do, I'll do the fluting for the pawn here, and then I'm going to do another video to do just to give you an idea of some of the backside stuff that I want to get in on this part so we can do the orientation. So what I'm going to do is I'm going to take I have a pawn turning drawing, and I've just pulled it up, and it's really the same drawing. I've renamed it pawn milling just so that I would be able to have just some different parts in here to show other classes as we go. So I'm in my design. I'm going to do a little bit of moving around here, and I want to stand this thing up, get a pretty good perspective of it, and then I want to start a new design. I want it to be in a spot so that I'm in the middle of the part. So right there looks good for me, and I'll rotate this thing back up again. And so the original pawn from Titans to CNC is not drawn with this extension on the bottom. We added a 1/2 inch so that we could hold it. When they made their parts, they made them on a multi-axis lathe, which was awesome, but we don't have that. So we did ours on a 2-axis lathe, and now we have a 4-axis rotor, and we're going to put our fluting in there. So what I want to do is I'm just going to draw a couple of quick lines to give myself some orientation. And these lines really only mean something to me as far as reference. They won't actually be part of the part. And as I go through this is a little bit of learning curve for me as well. I'm not super familiar with 4-axis in CAM, and definitely not in 5-axis with CAM. So there's a million different ways of drawing this. My roots are in CAD, AutoCAD, kind of knowing where you want to put things. So what I'm going to do is I'm going to put 2 points here. So a point here and a point there. That's my high point, my low point. Those will end up being my radiuses. I probably could have just went ahead and put those in as circles at that point. So let's just try that. Let's put these in as 375, and we'll do another circle down here at 375. Okay. Let's see. We'll also want a center line that runs through that. And as far as placement wise, I've not placed them in the correct positions yet. I'll move those as I do things. So I need to put some dimensions to my parts. So from this central point, I will go from here to the center of this, and it is going to be 990, 950, sorry, 950, so just what the print shows. And then looks like it's 250 up from the bottom. I've got my Titans CNC print pulled up over on my other screen so I can see it, because I'm not trying to reinvent the wheel. I'm using what they've already provided for us, and that's a pretty slick resource. So let's see, I'm going to do a dimension here, center of that to here, and it needs to be 250. My upper one from this point is going I'm gonna check just since I'm here. Bottom line here, 1.75. Yeah, just want to make sure that my math worked out, so I have my half inch. Okay, so I've got radius, or diameter, and a center line. I'm gonna take and draw another line, and I can do. Actually, I could probably just come in here and just do an offset of this line, and then just do 0.1875 and hit OK. And then I want to make sure that those lines intersect. They look like they do. So when you offset a line like that, it should come from center point, so you shouldn't really have a tangent issue. So I can trim out. Let me back up. Need to do a quick extension. Extend this line to the center point, or to the end point, this line to end point. Did not want to do that on the other one, so that's okay though. So I'll trim. So trim, 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 and then trim, trim, and trim. And so now I have essentially kind of half of my shape there. I'm not sure what I'd call that shape. I'll bring it around here. While I'm still in the drawing, I'm going to go ahead and go to revolution. I'm going to revolve this. This will be my axis, and I'll put it in there. I want to make sure that it's cut. So now I have my fluting. And so now what I'm going to do is I'm going to go to create a pattern, and I'm going to go to create a circle pattern, and I want to select my objects. Here's my object that I'm going to select. Yeah. And the axis that I want to select, I'm just going to select an axis, and I want 8, and I want them to be already spaced around it. I want them to go around the full diameter, and so that gives me 8 flutes that go around there. Hit OK, and I should be left with 8 flutes that run around the outside of it. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that looks right. And if I'm right, then I think that's what the Titan one has too. Yeah, 8 times. Okay, so at this point, I'm going to do a quick save just so I don't lose anything. Now I'm going to move into manufacture. So this is still my drawing that I had some turning on. So I got all my operations that are turning that are no longer working. Let me delete out this program. That program was left from me playing before. Our part is going to, I'll flip it around, sit. This section will be in the 4th axis. This part will be sticking out, and then we'll do our rotation stuff around here. I think what we'll try to do is use a 3/8 ball-nosed end mill for this fluting. There's a little thing that I don't like about it, but I don't think it's going to really kill us on it. So I'm going to do a new setup, and I got to change my machines, and what I'm going to go to, hopefully, there we go. I'm going to go to a milling operation, turning off. I have a Haas A-axis, and I'm going to use it. Still have some wonky orientation here. In just a second, I'm going to show you where I got that post. I've made a spot for you to be able to pull that post out. So let's see. That should be fixed size cylinder. And the stock diameter is going to be 1.486. And it can be, actually I might be able to just go from solid, or let's go from the model. There we go. It's still not 100% the way that I want everything, but it's going to be, it's getting closer. So I've got now a round shape. I don't want any stock around it, so I hit 0 on that, so no stock. Jump back over here and get some orientation going on. I want it to move to here, and so Z is up, so that works here. So I got my top, my Z up, my Z is up here, my Y is forward facing, my X is positive facing. I'll go ahead and go on over here. I'm going to call this program 150, and I'm going to use, I think we'll just use offset 54, so that's a 1, and if all goes well, that'll be my setup. So that is now called setup 3 for me because I've done this a couple of times. Oh my gosh, that is terrible. Okay, let me open Fusion back up again. And while I'm doing that, I've got Canvas open. If you look in your Canvas modules, you'll see this section here, VF3A axis. You can go in to this module. You can grab the machine posting from it and then import it into your Fusion, and then that way you'll have the same machine that I have. If not, you're going to have to make a VF3 with an A axis so that you get that rotary. All right, let's see what we have. I don't think I'm not really concerned about any of those at this point. So open this back up, see if we can figure out where that thing is at. And I think I put in my Titan chess set, I think I put a 135 in there. Let's see if I've got a pawn milling from today. Yeah, looks like 824. Okay, so this drawing is from our last save. We've got our flutes in there, so we're going to go back down through the milling. And so we'll go to manufacture. And we've got a setup. Again, it's our turning setup. We're going to go in and we're going to do a new setup. And it is going to not be for a lathe, but it's going to be for a mill. Turn milling on and turn turning off in our A-axis mill. And we'll come over here and we'll go relative size cylinder, and we'll pick our axis here. No stock on this because our outside of our part is already turned. That's probably okay. And we'll go over here. We'll go to, I think I did program 150, and I think I did one over here. I have not done something though. So let's see, I need to move still. And I want to go right here into this center point. Okay, so the reason why X0, Y0 is going to be in the center of this cylinder. So X is going to be center line, Y is going to be center line, Z is going to be center line. So we'll nest that thing right into the bottom of that, and that should be it. Let's do a save so we don't lose that thing again. Cannot save often enough. Okay, so let's get a look at the front. Let's fit it in. Get some perspective on that thing. And then I want to look at really top flute, which is going to be here. And I think what I want to do is just do a ramp in it. Let's see what the ramp looks like on there. I'm going to pick a tool. And I've got a 3/8 ball end mill right there. boundary, we want to do selection. We want to select this. And let's see what it looks like, and then we'll come back and do some cleanup work on it. Okay, so that's definitely not what we want. So let's go back into that. Now that could be that we don't want to use this operation of ramp, or it could be that we've selected a boundary, we know where we are, but we don't necessarily have all of our details worked out. So we can go tool on center of boundary. Okay, so that looks a little different. Looks like it stays in there just a little bit better, and it's doing some scalloping work down through there. I don't know if that's going to leave us with any kind of a smooth transition inside of it. So we come back here. We can go inside boundary. See what it looks like. Okay, so inside boundary seems to give us some kind of a problem. Let me turn these back on. No warnings, but it doesn't look like we've made a toolpath. Again, we have some kind of a little bit of a scallop here. Alright, so I'm still not really happy with what I've been coming up with for a profile. It just doesn't do quite what I want it to do. So I'm going to try something different, just to play around with a couple of new functions, at least new functions for me. I'm going to come in and come back to here and look at just some different things that I can do as far as working with this part. There should be some other things that I can do in order to get my rotary functions on this thing done. Fusion's really good about helping me to make some good decisions. When I can't get what I want going, I just need to try to play around with a couple of things and start to think a little bit more like Fusion. So I can come in and I could do this profile in a couple of these different things. I could either pencil it, I could run down it like this. The flow that we went with is okay. Parallel would probably also do something similar, but there might be another way that I can do this thing without having to do a bunch of other operations. So I'm just going to try jumping into my multi-axis and go to my rotary. So at this point, I'm going to go and select my tool, and I've got a 3/8 ball end mill. And if you'll look, I've modified the diameter on that. Let's go in and we'll take a look at that. And I'll explain to you why I've done this. What I've done was I've changed the diameter. Instead of 375, made it 355. Because part of the problem that this profile has, so I'm going to go ahead and accept it as is for right now. We can come back and play with it. I need to be able to extend on down here just a little bit. I think that 3/8 end mill is going to give me a little bit of a problem. So I'm going to be in rotary, and I'm going to play around a little bit in rotaries. Make sure I'm down here in this second setup. So I'm going to go down here and make sure I'm grabbing rotary in it. Select my tool. It is the 3/8 ball end mill, And so now what I'm going to do is I've got to kind of go back and forth and figure out how to put this thing into its place. Because again, it's not quite in the direction that I want it to go. It's in a different orientation. So I'm going to take my rotary and I'm going to select the rotary axis. That is my rotary axis right there, my Z. That brought me into a pretty good place where everything else looks like it fits pretty good. Now I might have a little bit of a problem for my origin. I'm gonna make sure that the Z-axis is all the way, or the X-axis is all the way back there. And now, bring this down. This would be stock OD. I don't need to have any stock, any clearance on that at all. My outside's completely turned. So let's go back. Looks like I'm in the right orientation. I've got my end mill coming in from the side. It's coming in, and I would expect it to come down Z, but that's okay where it starts. So let's start kind of just going through these selections. I need to look at my model, and I want to figure out what it is that I want to turn and what it is that I want to avoid. So I can go ahead, let's select this model. And then down here it's got a section that says avoid touch surfaces. So I'm not sure, does that mean to avoid those surfaces or to touch those surfaces? Let's just play with those. There's 1, 2, 3. I'm gonna go all the way around. Did not get what I wanted. That's trying to mill the entire thing, right? So let's go back and see what we want to play with. Alright, so that actually didn't select any of those surfaces. So let's do this. Let's go in and let's click what we don't want to machine. There's a way that I can just flip those two things around. No. Not happy with those faces. Go ahead and change this tolerance. I wonder if I could just hit touch surfaces, go here. That might be my winner. Hopefully it will avoid all of my other surfaces. Alright, so let's just see what that looks like. Okay, so it's definitely doing some milling around the outside of it, but that's probably not what I want. So let's go ahead and save. is there options to change the direction that I go? So that looks a lot better, right? So I've got some lead in, lead out that I'm not super happy with, but I don't know that I'm exceedingly unhappy with it. And what I'm talking about is this radial moves as I go in and out here. So green, in and out. So I'm gonna go back and play around with those just a little bit. Change those to 0. See what they look like. And then that extends better. I'll come back and bring some lead into it. Not really concerned about the lead out, I don't think, at this point. After this generates, I do want to do a save. I'm going to go back up to my setup, run this entire thing. Quite getting a full form on it. Looks like it needs to go down further. Top part looks okay as it leads into my part, but the bottom doesn't look like it's going down far enough. Not done anything with RPM yet either. Let's look at it. I don't think that that's going to help us any really. Don't want to leave any stock. And that's taken care of. That looks like. All right, so that is actually getting shorter. Back to that's actually cutting less. Let's look at that. So that's definitely not what we want. So no stock to leave. No smoothing. It's really important to just play around in Fusion or whatever program that you're using to start to know what the commands are. A lot of the problems that I think that we run into is that everybody's just waiting for that last picture of what the screen should look like or what their options should look like. They're really just looking for, show me what all 5 of these tabs should look like so I can hit OK and be done with it. And I think that that's an okay place to start. But that only works if every situation and scenario is set up identically to this. So the more that we can play around and start figuring out what rotary really means to us, is going to give us a lot more benefit and a lot more help, even if we have to play around just a little bit. I know that our time is valuable, but at the same time, these are learning experiences for us. So we want to really spend as much time as we can or as much time as we can in order to get these things right. All right, so at this point, this is set up with our ball end mill. It's a modified 375 end mill, ball end mill, and it is tool 6. So I'm going to go ahead and output the code. So let's see, let's do a setup. This is our A-axis machine. It's going to be our program 150. I don't think I really need to change anything here. Anything there would really be preference wise. Go to my operations. I just want to do setup 2, rotary 3. I'll probably change that along the way. And overwrite that file. I've made this program like 15 times. So now it's important again that we know code. So we're coming in, spindle 6000, G54 for our offset. We are going to come in and rotary to negative 90. We're going to turn our coolant on. It looks like we're going to do a X offset with Y0. That makes sense. Fast feed down, or fast feed over to that position. Then here's our tool length offset. We're going to go to 743. That's the outside of our part. Feed down a little bit, or I'm sorry, wrap it down a little bit to 706. That's probably close to the outside of that diameter. Feed down to 696. And then here we're doing an angled cut at a 90 feed rate. Then we're going to go up, and looks like we got a rotation, a rotation, and a rotation to get to 45. Let's see our next rotation, if we are following that pattern. So 360 degrees divided by 8, that means every one of those is on a 45 degrees. So I'm not sure what these incremental movements of 75, 60 are, because I think you should be able to go straight to 45. But it looks like it does that in all of them. So it looks like we have 15 degree incremental movements as we go around there. Now that might be something that we can change as we go. So we've got so we go from 90 to 75 to 60. So those are all 15 increments. Let's look back at our rotary, and not our tool, our rotary. I saw a spot in there that said step overs in 5 degrees, and I wonder if that can be changed to 45 degrees. Wonder what that would look like. Okay, so here it doesn't change anything, but let's look at our program. And making those incremental movements at 15 degrees outside of the cutting area isn't that big of a deal. It doesn't change anything here. So that's something I want to do a little bit of investigation on and figure out why we move from 90 or from negative 90. Why don't we move these two lines? Essentially I feel like could be eliminated. 90, 95, 130, 135 could be eliminated. Okay, so now after we're done, we finish our last one at 270. It goes up, 743. Then we're going to go home to Z, X and Y, rotate back to A0. And then looks like we're doing an X negative 1.5 move. And then we do a Y0 move. Probably do a little bit of tweaking there as we run the code. But I think that looks like a usable setup. As far as tool number goes, doesn't really matter for us. 6 is fine. Um, we'll leave it alone like this. If you change the diameter of the tool, you're going to be able to get a little more length and cut. It won't change profile for us because the tool is 3/8 of diameter. All we're really doing is extending down how far it goes. We'll definitely want to run one scrap piece before we get started just to make sure that everything looks good. I would really encourage you to get familiar with rotary, as we're going to spend some time in 4-axis here for the next few weeks as we do not only the fluting, but the bishop has a little notch on it, and then it gets progressively more difficult as we go. We will be flipping back and forth between 3 and 4-axis for a couple of operations. And then that's why it'll be important to have your orientation pin set up so that you can go back and forth with it. So, okay, I'll stop here. Please spend some time trying to get a good handle on rotary, and I think that we'll probably all get better as we go. So, all right, hey, have a great weekend. I'll do one more video on just the orientation pin on the back side, and then we can go from there. See you.